Hey folks, in the previous session what we have done is we have find the TF-IDF score with respect to the some question that we have. Along with that, what we have done is we have also find all the features having all the TF-IDF scores, and we have created a dictionary often known as word to TF-IDF. And the moment I will pass some key, it is able to return some TF-IDF score for us. That's what we have done in the previous session. So in this session, our real world problem is all about, first and foremost, we need to find the word to WAC representation of our data. Again, just to implement something known as word to WAC, again, there are tons of libraries. We have something known as Glove. Along with that, we have something known as GenSim. Along with that, we have something known as Space. Again, there are tons of modules. In general, Glove is nothing but a global vectors. Again, the concept of word to WAC and Glove are similar, but there are some minor differences between word to WAC and Glove. So just to implement this word to WAC, we will try to touch upon one of the extremely used module often known as Spacey. Again, NLTK is used in most of the cases, but even most of the data scientists in context of real world, they use NLTK just to access to many algorithms to get something done. But if I will talk with respect to Spacey library, Spacey typically provides the best way to do it. It provides the fastest and of course most accurate of any NLP library. So first and foremost, you need to install it using something known as pip install Spacey. This is a command just to install this Spacey. You have to just execute this line of code and Spacey module will get installed in your local environment. The moment I will install it, so I will say, hey, can I import the Spacey in my Jupyter notebook? Again, just to implement something known as word to WAC, there are some modules that are available in this Spacey package. Again, there are typically, I think if I'm not wrong, there are 3 to 4 modules that you can think of depending upon your system specifications. So one of the sub modules that you can think of, something known as en_core_web_sm. You can just think of using this and you are done. So just to install it, you can say as Python this -m, you have to use this Spacey. Then you can say, hey, can I download something known as English_core_web_sm. The moment you will execute this line of code, you will end up getting this module which is all about core_web_sm in the local environment that you have. Let's try to comment it out because I have already this module in my system. Now once I will install it, first and foremost I have to load this. So I will say, using this Spacey, what I will do is I will say, hey, can I load this package? Cool. Let's store it in, let's say in NLP. Let's store that in. Let's execute this line of code. So if I will print the NLP, which is all about the object of nothing but this one. Now the fun problem is all about, we have to find the word to WAC representation of our data. So if I will say, let's try to pick some random data. So I will say data of question. Let's say data of 0th index. Cool. Now this is the data that you have. Now just to implement something known as word to WAC on top of this, what I can do is I can say, hey, again, word to WAC in a nutshell is all about, we have some word, given a word, it returns some vector representation. It means I have to consider each and every word and it typically returns a vector representation of that. So what I can do is I can say, hey, can I iterate on top of this, on top of this string that I have? Can I iterate that and can I find some vector representation of each and every word that we have? Now let's try to do that. So I will say, I have to just use this NLP and I have to just pass this data over there and let's try to store this in, let's say in document 1. Cool. Let me just execute this line of code. Now I have to say as for word in document 1, then here I have to print the vector representation of each and every word. So if I will say, let's say word dot vector, the moment I will press tab over there. Now this is the attribute that we have. And if I will execute, now you will see this is the vector representation that we have. Now just to make things more clear, along with the vector representation, you can also think of printing some word that denotes, hey, this is the vector representation of let's say what. So let's try to make the output more user friendly. I will say, hey, can I format my output using something known as this output formatting way. So I will say I have to just add these two placeholder, and I can just receive the value of placeholder using my format function. Cool. Now the moment I will say this, and after printing, you can also think of printing something known as new line over there. Cool. Let's try to execute this line of code. Now let's try to debug the error. It says, hey, you have some error in this line of code, and it's all about a syntax error. Again, that's my bad, just because of this opening parenthesis. Good. Let me execute this. Along with that, also remove me this one. Now, before executing, you have to also mention your word. Cool. Now, this is the vector representation of the data, or of with respect to each of the word that you have. Look at this. This is the vector representation with respect to what. Similarly, this is the vector representation with respect to our is. That's what our output says. Just because of these three lines of code, look at the output that you are getting. How you can think of formatting your output, and just to make your output more interactive, you can think of something known as placeholder over here. Again, this is what actually my word to vec stands for. If I have to apply on top of, let's say, this data, this is what I actually stands for. Now let's try to enhance the word to vec, or let's try to use something known as tfidf. Let's try to use something known as tfidf weighted word to vec. Let's try to understand this, and again, we've already touched upon what exactly this stands for. Let's try to understand how to implement this in Python. Let's try to understand this. So just to implement this Python, let's try to understand, again, let's try to pick some basic document or some basic string. Let's say I have a string as, let's say I love machine learning. Let's say I love machine learning. And with respect to I love machine learning, I need a vector representation, but considering, let's say, this algorithm. How can I do this? So what I will do is I will say, hey, first and foremost, let's try to pick each and every word, or let's try to pick each and every token. So I will say, hey, I have I, then I have love, and then I have ML. So using your word to vec, we are able to find the vector representation of this I of some size, let's say m cross n. Similarly, with respect to love, you will end up getting some vector representation of size, let's say p cross q, or let's say m cross n, doesn't matter. Similarly, with respect to machine learning, you will end up getting some vector representation. So imagine I is, let's say 0.6, 0.7, or let's say 2, or let's say 1, or let's say 0, 0, or let's say 1.1, 1.4, whatever else, or let's say 2.1. Let's say this is a representation of y. I'm just assuming, this is not a exact representation. I'm just assuming over here. Similarly, with respect to love, we have some representation. Now here comes the important thing, which is all about the TF-IDF. Now what we need to do is, we need to say, hey, what is the TF-IDF score of this I? Imagine TF-IDF score of I, let's say 0.12. So I will say whatever matrix we have to just multiply it by TF-IDF score. Let's say 0.12. Similarly, let's say the TF-IDF score of love is, let's say 6.7. So I will say I have to just multiply it by 6.7. Whatever matrix or whatever vector representation of I have with respect to word to vec, or whatever representation of love using word to vec, I have to just multiply it by TF-IDF score. Similarly, let's say its score is, let's say 6.1. So I have to multiply it by 6.1. Then whatever values we will get, we will say, hey, can you do a simple addition? Can you do a simple addition of all three matrix or all three vectors that you will get? Then whatever matrix I will get, let's say of some x1, x2, x3, some y1, y2, y3, some z1, z2, z3. Just divide each and every value by 3. Or in a nutshell, you can say, hey, can you find the mean of all the three matrix that you have? It means the final mean that you will get, you will end up getting this value. So this is basically, you can say, your TF-ID of weighted word to vec. This is what you need to find in the upcoming session. Again, if you are able to understand this pseudo code, what I have explained you, writing a Python logic is quite straightforward. Again, for those of you who are not able to understand this pseudo code, please feel free to ask with us in the Q&A of the course. So that's all about the session. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.